Everything's all updated together, and this is where we're at. That is nasty. Alright, this is Nigel with Iron Raptors Airsoft. I'm sort of the tech guy, and I thought I'd make a little video of what I've done to the G&P Phantom. And in the meanwhile, I might as well show you maybe some explanations to why I went this way. So, to start, some people are wondering, why in the world do you invest so much money in airsoft? Well, for some people, they like to take the basic, G&G combat machine with some standard parts, and they're good. It keeps on working. Now, I thought I'd show you some components I pulled out of some previous guns to kind of explain the difference between a full build versus a cheap build. So, to start off, see, this is your piston out of a $100 gun, a CSI Star XR5 that I had before. I ripped all the components out and tried to make a DMR out of it. Broke the gearbox. It literally cracked right there. Piston spring just shot that front end off during testing. So that was not good. Anyway, so what's the difference? Alright, well here is the CSI Star piston and piston head. Here is a standard G&P, which you'll have in almost 90% of their lineup. And then this is what came out of the Phantom. Alright, so here's your differences. Now, traditionally, you don't always get to have these metal teeth at full stroke as you would on some other cheaper airsoft guns. So it was nice for CSI Star to do that. However, their big downfall is the level of polymer quality on this piston. It is a very cheap polymer. It's hard to pick up on camera, but the type of plastic it is, it doesn't have a lot of strength. It doesn't have any reinforcement. Whereas your mid-tier, your standard G&P, this is a different type of polymer. It's reinforced. It's got some extra strength to it. It can withstand a while, which is something you're looking for. Now, we move towards the G&P Phantom. This is where you start moving to, you're going to have a nice ported piston, which actually the CSI Star did make an attempt at it, although I'm not sure those ports do anything with how small they are. It would take a while for air to push through there. But the other thing you see is they have a spacer to correct the angle of engagement. Now, some people don't know what angle engagement is, but that is how the sector gear contacts the very first tooth. So you want to be at a perfect mesh at first contact. You don't want to contact it early where you're off angle or too late. You want a perfect mesh when you first grab it. It's nice and strong, little wear. So sometimes in order to do so, you have to remove the teeth, but G&P already removed actually 2 teeth in this case. I'm a little concerned about that. We'll see how that goes with this M170 spring, but we'll get to that. But you'll see some teeth removed in order to correct angle engagement so that the sector gear does not hit the second tooth before it hits the first. Now you also see that, hey, what's this ugly grinding? Well, I'm running an 8-tooth DSG, so that means there's going to be 8 teeth pulling the spring back. And then whenever that last tooth lets go, fire on that gap. Then the piston will be drawn back again on the second set of teeth. That is a sector, hence dual sector gear, 2 sectors. Fires the piston twice per revolution of the sector gear. Whereas your standard has only 1 sector, all the way on this side. See, they figured that's just a waste of time. Why isn't it not pulling the piston back and any over here? And thus DSG was born. So anyway, back to the pistons. You see that the G&P Phantom had these weight reductions in the top from factory. Now, they still has some ribbing to keep some strength in there, but this reduction in weight helps to make sure that the piston can fire fast enough before the gear comes back to pick up the piston. Because you don't want the gear to reach for a piston that it's not fully seated. That's a big no-no. You'll start getting some stripped piston teeth, or even worse, your gears. But generally, the piston teeth are designed to fail before your gears. That way you don't have to replace gears often. It's only pistons. So that's why that is. You'll have cheap gears because you want them to fail. They're easier, they're cheaper. So, food for thought. Anyway, so what I did is I started drilling out some weight reduction. Some SHS pistons have massive holes going through the rail. However, with the already reduced weight up top, I didn't want to risk that, so I just stuck with the standard, they call this Swiss cheesing. So, there's your difference in the pistons. It's mostly the polymer quality of the piston. And you don't always want to have a full metal rack. It's not necessary except for the last few teeth whenever the springs have full compression. But whenever you're doing a dual sector gear build, you're going to need those first teeth to be metal because of the stronger spring, and you're only pulling the piston half back. So, next thing, this is also out of a $100 gun. This is your standard spring guides. You'll have a little metal nut literally glued in there for your spring guide bolt that comes through the stock to anchor the spring guide in place so it doesn't wiggle around while the spring's firing. However, the polymer's not all that strong and it's not a very good surface to rotate around. Now, this gun did come with a little washer to help, almost like a shim on a gear. However, if you spend the extra dollar on some nicer spring guides, they'll come with these nice bearings that will allow the spring to rotate without binding inside the gearbox. So you generally want to have a bearing on each end. Now in this case, there's no bearing on the piston head with the G&P, so it's not fully optimized. However, looking for the bearing on the spring guide, that's very nice for making sure the spring is nice and free and only doing compression and no torsion. That's kind of the idea there. Alright. Next up, let's have some explanation on what I'm actually doing with this gun. So again, I'm changing out the standard single sector gear for a dual sector gear setup. Now, I'm keeping the stock G&P gears for now, but I do have spare Siegetek 20-to-1 ratio gears on hand. That way, in case these do shred, I do have backups and plenty of shims to reset it up. Now, one thing is kind of hard to tell, and I'm not sure I'm going to be able to pick this out. I don't think I will. Let's see here. There it goes. This G&P gear in this Phantom has a recessed cavity, if you call, counterbore for an SK, I think it's SKF 8mm bearings is what these are. And that's not common to have a bearing on top of the bearing that's already in the gearbox. So I basically have a bearing on a bearing to reduce friction in between the bevel gear, which is going to rotate the most. So see how this spins so much faster? That's your gear ratio. In this case, this is a 20-to-1 gear ratio. So that means that this sector gear is going to rotate one time for 20 revolutions on the motor pinion, right? Now, in the Phantom, it actually comes with an ultra custom turbo. It's not a lot of specs on this motor. It's really hard for me to find it. But there's a little chart that I found online, I should put that in the video, where it kind of slots itself a little under on torque compared to the M180 Satan. And it's got a decent amount of speed. They grade it as 5, I think, on their scale. So I'm not sure if a high-speed motor like this will work in a DSG or not. Usually you want to have a high torque motor for the strong spring, but I think with my combo going a 20-to-1 gear ratio and a very strong neo magnet high speed, it might work out. So we'll see how long the motor lasts. Another detail I have not shared is what is the difference between having the cheap motors and your fancy motors? Well, cheap motor in left hand, ferrite magnets, plastic heat shield on the bottom. So this is supposed to radiate the heat away from the motor, and plastic's not very good at that period, and it'll melt pretty quickly at much lower temps than a nicer motor, which will have a metal heat sink, as well as other nice goodies on the inside. I'm not a good motor expert, but the big thing for me is neo magnets are much snappier, much faster response when pulling the trigger and the time it takes it to get to full torque. So, and brushless motors by VFC are gonna be a huge capitalization on that advantage, but they're still working their way out. So, now the next thing that we're doing with this gearbox is you may notice that there's some fanciness going on here. In your traditional gearbox setup, you will have a little combo here where you see how right on that trigger contact there's already some little bit of melting going on there. Well, that's because I'm throwing 11.1 volts between this contact and these contacts here. So whenever you have this pressing in between, that 11.1 volts is trying to arc across that. Now, what this fancy bit here is doing is this is MOSFET controlled. So, in a MOSFET controlled setup, you're going to have a positive wire going essentially straight to the motor, and then the difference is your ground control. From there, I'm a little shady. I'm not an electrical engineer, but the summary of it is imagine you have, instead of 11.1 volts going through that trigger setup, you just have a half volt signal that in this case is an optical sensors on this gate Titan trigger. See, you have the 5 optical sensors that can tell how far I pulled the trigger. That's why there's 5 programmable settings for trigger sensitivity. And on top of that, it also has a detection for, on the back side of this sucker, for being safety, semi, and auto. So you no longer need the stopper lever on the trigger to stop from pulling back. So you'll be able to pull it back, but whenever it's in safe, it won't fire. It'll just pull all the way back and no response. So it's kind of like pulling the trigger on a gun that's not cocked, if you will. You still use your standard trigger with trigger spring, although you have to be very careful when assembling together so you don't damage any of the circuit board when doing so. Alright, well, enough jibber jabber. Let's move forward. Alright. Now another couple tricks for DSG builds. Because of how fast you have to have the piston and nozzle return, some other tricks people try is they shorten this little, I don't know what you want to call this, plastic fin, if you will, from the tappet plate that's being driven by these 2 posts. See, this post, as the gear rotates, pulls back the tappet plate. And that pulling it back allows a BB to load. And then once this is done pulling on it, it fires the nozzle back to seat a new BB into your hop-up. So by cutting off a chunk of this fin, it allows the tappet plate to release sooner to load the next BB. Now, that's kind of the opposite direction of what you'll see in higher quality setups, where if you're going a single sector gear build, you'll have this little chip here that makes a longer tappet plate duration to ensure you always feed a BB. Now in a single sector gear, that's pretty acceptable. It's fairly standard. But in a dual sector gear, you're always worried that you'll misfeed because your air nozzle didn't have enough time to retract and well, sorry, it wouldn't be a missed feed. It'd be more of a loss in FPS. It didn't have time to fully seat against your hop-up bucking. Yeah, let's go with that one. That's a better explanation. Okay, anyway. Now, what we want to do is start getting everything in position. So you get this piston in here. There we go. Now we'll start getting the spring in there. Now I like to do the tight wrap coil end on the spring guide. I've never heard anyone say yes or no on which way that's technically supposed to go, more or less a guess. But I do believe that's the case. That way it has a nice bind on the spring guide. Anywho, need to get this anti-reversal latch in here. What this does is what can also lock up your gearbox, is this prevents your gearbox from rotating backwards in any situation. Oh no, that's okay. I haven't had mess with this yet. Okay, first off, you need to go back in your home. Okay, my signal wire is deciding it's going to get in the way of my anti-reversal latch here. See if I can move it out of the way. Might be low enough. Yeah, that's low enough. Alright, cool. Basically, it's all about routing the wires where the motor shaft goes through in a way that you don't rub the wires down. That's kind of the cool thing about the G&G G2 gearbox. It has a shield to protect your wires. I thought that's just nifty. Alright, so we have that all in there. Now what I want to do is I want to deal with getting the spring guide in place before the trigger combo. There's a good reasoning behind that, mostly because of the fact that this don't do that. Okay, that's it. You're off. You just almost stole my gearbox right off the desk. All right. Anywho, this spring guide is absolutely obnoxious to install into your gun. I'm not even joking about that. It's especially whenever you're working with these stronger springs. I really recommend nice screwdriver with a snubby end so it doesn't go so far that you might stab yourself accidentally. Not joking about that. Alright, so I'll have you somewhat in the position. Fill that. That explains it. I really wish these springs had a way to just stay in there, but can't really glue it because you need it to rotate. Okay, you're in there. Now for the nightmare. So here's the deal. See these ears on this spring guide? They have to fit inside this slot and this slot at the back of the gearbox. This is what makes that neo magnet. Okay, I'm gonna have to separate that later. You gotta watch these strong motors, they'll steal anything. Okay, here goes. Ooh, okay. Coming at a different angle. These are treacherous, to say the least. try not to break everything else in the gearbox. Oh, Lordy. Okay, pumps need to break. I'll get back to you when I get that. Okay, ladies and gentlemen, the bastard is in there. That is not a fun deal, in the least. Alright, now I have to get the trigger back in and the trigger plate on before I can close this shell. In case you didn't know, I hate this thing. Okay, there we go. No! There it goes. Okay, so I'm going to let the universal latch rest on the bevel gear there. Let's try a different approach. Nope, bad idea. I do not want to break that thing. Okay, now the wires have to be seated. Make sure the piston hasn't twisted. Now we gotta get all the gears to align. Something's not lining up. Spring guide's not playing ball right now. It's hard to see, but it's not going into its lower slot. Okay. arms need a break. I'm gonna put in some screws temporarily, then I'll jump back in on this. Okay, we're good. It was the tab plate. Now I got that free, so you can return. Now the gearbox can sit flush. Now I'm gonna finish tightening the screws. All I was doing was keeping them partially tightened just to the point that they're holding the same amount as my hands were while I determined what was keeping it from shutting. Luckily, just popping this down meant it must have been jamming with the shim. I noticed it was bending upwards earlier. Still don't like these screws up top. I don't have a good fit on an Allen. I'm going to just kind of get them there, but not keep the Allen on them. See, yeah, that's no. I'm gonna have to replace those pretty soon, I'm betting. All right, now if you don't know, for tightening anything that's metal on metal, generally what you want to do is spread the material out. I guess this is good practice for anything really. So you start doing your initial torque in the center. You just kind of crisscross and work your way out. Now what this will do is it'll make sure that everything's not pinching the metal together and putting it in the wrong spot. It's just nice and even. And now once I have that initial torque down, I'm going to go and double check everything. I don't want to put too much because it seems these screws can strip easily. I'm not a fan of that. Okay. It's all in there. Yep. Woo! Well, I'd love to show you how it works in the new gun, but I'm gonna paint it. Surprise! Oh, by the way, dumb thing, if you didn't know, when you paint your airsoft guns, anything that's supposed to be a slip fit won't work if you added paint material. The factory paint layer is very, very thin, so when you put on a layer of primer and a layer of spray paint, this all doesn't move anymore. Like, I got that to break free, but the bond between the inner diameter of this passage and the outer diameter of these little shafts, guides, whatever you want to call them, yeah, that's kind of press fit right now. I actually have to hammer these alternating to slowly work it out so that I could get the centerpiece out wherever I put it over there. So, yeah, a little tip for spray painting. If you want it to move, don't paint it. That's just side note. As far as this goes, I'm super excited to try it out whenever I get everything back together. But until I get everything back together, it's not going to be much. I guess, well, for now, where's the grip? I can load you up real quick. I have too much curiosity. I must know. Whenever you're putting these grips on, make sure you don't pinch your wires too between the grip and the gearbox. I've done that mistakenly my first times. Alright, screwdriver. Screwdriver! There you are. Alright. Here's my grip screws. Oh yeah, by the way, cheap guns only come with 2 screws. Expensive guns come with 4. More you know. Alright, now this is always a tricky bit. Because you can't let the screw fall off. Screwdriver. But you also lose like all vision unless you got a flashlight on your head. Come on, find your home. Oh, there it goes. I don't want to fully tighten that yet. Ooh, okay. Don't do that. Not in the mood to go find you. This one's being main. For real? You have one job. Alright, and another thing that some of you may not know, but in every single G&P, your connectors to your motor are actually screwed on to the motor terminals. Every motor out there, oh goodness, will you stop it, you Neos. Now those are magnetized. Anyway, just about every motor has a threaded option or the little prong option. So you can do either or. So don't freak out if, oh no, you don't have the thread on, or, yeah. It's 2 options. I personally prefer to thread it on, but for the purposes of testing this out, we're going to stick with what we got, right? So we need to make sure that the ground is going to front, which is kind of backwards, but that's how this is wired. Okay, this connector's not having it. Come on. I need you to bend. Yeah, that's not bending at all like intended. Okay. Need a pair of pliers. Go. Not certain why they had to go and make their wire length so screwy. Alright. Now with motor grip screws, well, I guess you could call it the motor grip plate, I think. You have to be very careful with their alignment. It's very easy to mess these up. I usually don't like to start threading until the plate's pushed all the way in. They're very, very picky. Okay, I'm not using you for that. You're just gonna bend around. Throw a fit on me. Let's back out the other side first then. Man, why are you giving me this much damn trouble right now? There it starts to go. Now let's get the back. Yeah, that ball end's starting to die on that one. That's why I'm trying to use this for final torques. Oh, that's catchy. Everyone's in place. Let's do a diagnostics check. Group on the tables, I can show you what's going on. What is all this that I got on my battery? It's nasty. Okay. Interesting. Haven't seen this before. Alright, ladies and gentlemen. I found out that the other battery I bought was a dead battery. And I also had to update the firmware on the programming card. So everything's all updated together, and this is where we're at. That is nasty.